In this problem, we have a table that shows exponential decay of medicine in a person's bloodstream over time. Since the problem is calculator based, it's designed so that you just plug in these values and then have the calculator figure out what the equation is. So going to stat, edit, I'm going to plug in 1, 2, 3, 4, 5 in for my x values or my t values, and then 198, 163.35, 134.764, 111.180, and 91.724. So I'm not going to have to calculate anything. The calculator will do it for you. Stat, calc, and go down to exponential regression, and then I'm going to store that into vars, yvars function y1. It's going to give me a bunch of stuff there. Notice it's in the form ab to the x, and they give you a as 239.99999 and then 0.825 as my decay. So it's going to look something like 239.999 0.825 to the x. And since it's all stored in my y equals, I'm not going to have to worry about rounding or anything like that. So then, according to the data, when will only 10% of the initial amount remain? So I want to set this entire thing equal to when there's only 10% left. So I'm basically going to take 239 multiplied by 10%, which is just 0.10. Now, like I said before in the previous problem, when you divide by 239, these end up canceling. So you could have jumped that first step and just set it equal, take out the 239 and just set it equal to 0.10, which is what I'm going to try to do here. So I'm going to delete a bunch of these values and then just set it equal to 0.10. Change my window. I don't need anything very big. If I look, I can see that it goes up to, my answer choices go up to 235. So I'm going to check out all the values from 0 to 2, let's say 250, going by 10s, and then since my y value I only want at 0.10, I'll only go from 0 maybe up to 0.2, going by 0.1 maybe. So graphing that, you can see that it reaches 0.10 pretty quickly. So looking at the largest answer choice, I could probably rule that out. So let's find the intersection. First curve, second curve. I don't feel like guessing. The intersection is going to be right there at 11.969 years. That would be this answer. Just for a little bit of log practice, if I were at this step, if I wanted to do some of this by hand, I would at this point take the log of both sides. Doesn't really matter what base you pick. At that point, you can see the x is going to come down. x natural log 0.825, natural log of 0.10. It may have been better to choose log base 10 since this is a factor of 10, but it doesn't really matter since I'm going to have to use this value over here anyways. So last step would be to divide by natural log of 0.825. And that would be my x value. Now, if I were to do this, I would want to plug in as many of these decimals as possible, otherwise it would be slightly off of the answer of 11.969. So let me try that. It's natural log 0.10 divided by natural log, and then I'm going to show you two answers. One, I'm going to plug in as many of those decimals as I can, 0.825006907, just to keep as much accuracy as possible. 11.969, 11.969. So I was able to keep a lot of that accuracy there. But if I were to try this again, maybe deleting a lot of this, I would still get some of that. And notice, most likely that's because there are a lot of zeros after the 0.825 before any other numbers. So luckily there are no other answers that are close, so that is a more obvious answer.